Okay, let's look at this question. It's from 2023 June, question 8. And it's a question about vectors and its application in kinematics. A square floor space ABCD with center O is modeled as a flat horizontal surface measuring 50 meters by 50 meters as shown in figure 5. The horizontal unit vectors I and j are in the direction of AB and AD respectively. All position vectors are given relative to O. A small robot R is programmed to travel across the floor at a constant velocity. So this one is a very important condition, and we're going to use it in our questions. At time t equals to 0, R is at the point with position vector minus 2i plus j. So approximately is like here. To make it clearer, that's just based on point O. Let's just draw like a Cartesian coordinates. Make it clearer so that we can see that it's like in the second quadrant. Let's label it R0, and it's minus 2, 1. All right, at time t equals to 11 seconds, R is at a point with position vector 9i plus 23j meters. So approximately it's moved to the first quadrant, like here. At time t seconds, the position vector of R is r meters. Find in terms of t, I, and j an expression for R. Okay. How to do it? So firstly, we don't know anything about R, but then we know that R is we know this formula. R equals to R0 plus V times T. So R0 is the initial position vector, V is the velocity, and T is the time. Now, what do we know about this? We know about R0, which is the initial position vector here. And we only need to figure out what is V. And what is V? V is the velocity. And since the velocity is constant, we can just find velocity by this condition. And velocity is equal to the displacement divided by the time. And what is displacement? Displacement is the difference between the position vectors at time t11 and time t is equal to 0. So let's figure it out. So first we need to find the velocity and then substitute velocity into this equation to find out r. And that's it. Vr equals to change in displacement, which is equal to the final position vector, 9i plus 23j minus the initial position vector, minus 2i plus j, and then divided by the time. The time is 11. Okay, calculating that, we got 11i plus 22j divided by 11, which is equal to I plus 2j meters per second. Okay, now figuring out v, we're now going to substitute this into this equation to figure out r. So r equals to r0 plus vr times p. What is r0? R0, look, r0 is here, minus 2i plus j. So it's minus 2i plus j plus I plus 2j t. And you get minus 2 plus ti plus 1 plus 2tj. I'm just gonna omit the calculation process and focus on the methods. Okay, now move on to B. A second robot S, is at point C. So this sentence, we can just label it. So S is here. And what do we know about the coordinates of S? It's 25, 25. Okay? At time t equals to 0, S leaves C and moves with constant velocity minus I plus minus J meters per second, which means that, yes, it's very obvious. At time t seconds, the position vector of S is S meters. Write down in terms of t, I, and j an expression for S. Now, I think that part B is easier because we can just directly apply this and we don't need to find anything. It's because we know R0 and V, okay? So let's just change R into S to make it just to distinguish from question A. Okay, and what is S0? It's the initial position vector of S, which is 25I plus 25J plus, what is the velocity? Is minus I minus J times T. And eventually you'll get 25 minus Ti plus 25 minus Tj. Okay. Part 3, show that SR equals to this vector. How do we do it? Let's just look behind. In question A, we find out the position vector of R, and in question B, we find out the position vector of S. And now we're going to find SR. How do we do it? So there's an equation. So first, let's just a very basic principle in vectors. For example, this is O, and this is A, and this is B. How do we do it? So according to the principle of triangles, OA plus OB, sorry, OA plus AB equals to OB. This is intuitively, it just means that there are two ways of getting from O to B. Either is directly from O to B, it's OB, or we first get to A, OA, and then from A, we go to B. And so from this equation, we can know that the vector AB is calculated as OB minus OA. So what do we know about this pattern? So to find OB, we don't use OA minus OB. We just flip the letters, use OB minus OA. It applies to every case. So in this case, SR, we can use OR minus OS. So what is OR as calculated above is minus 2 minus Ti plus 1 plus 2Tj minus 25 minus Ti, or let's move it. Plus 25 minus Tj. And you will get 2T minus 27I plus 3T minus 24J. So this is exactly what this question is about. Okay, and last one, B, find the time when the distance between R and S is minimum. All right, now we know about this vector, and so what is the distance? The distance about the vector is, okay, right, if a vector is AI plus BJ, what is the distance? It's the modulus, which is square root A squared plus B squared. Okay, let's just calculate distance SR first. Distance SR is equal to modulus SR, which is equal to square root 2T minus 27 squared plus 3T minus 24 squared. And now we're going to find its minimum. Okay, whenever you see the word find the minimum of something, it reminds you of what? it reminds you of differentiation and then finding the minimum point and the maximum point. And we're going to use this method. But here, if we directly find its derivative, find this one's derivative, it's kind of complicated because it has a square root on the top and we're going to use chain rules. It's very complicated. So what we do is we first square it, okay, to make it this one. And we call it ft. There is a function called ft. And the minimum of this function is also the minimum distance. Oh, actually, what I'm about to say is that the minimum, the time where the distance is a minimum is like the same in both cases. We're going to find the same result. Okay, now let's do it. First, we need to simplify this one quickly. So it's 4t squared minus 108t plus 729 plus 90 squared minus 144t plus 576. And collecting like terms, you get 13t squared minus 252t plus 1305. Okay, and now we use differentiation, set the derivative equal to 0. So what is the derivative? It's very easy to find. It's 26t minus 252. And we set it to equal to 0 to find t. And that's it. All right, t is equal to, if you do the math, it's 126 divided by 13, which is approximately equal to 9.69 seconds. Okay, now we find out the answer to question D.